This is chapters 3.5, 3.6, 4.1, 4.2, and 4.3 pre-assessment. This will help you prepare for the assessment on Tuesday and Wednesday. And take a look, take a listen, take some notes. So it says sketch the graph of each line, plot 2 points, and label the coordinates. It doesn't matter if it's in standard form, point slope, or slope intercept form. I'm just going to ask for 2 points and label the coordinates. I know before I had you do 3, but we'll just keep it simple. All 3 linear equations, you can, all you need to do is 2 points. So we have this as a standard form. We have 3 linear forms. We have standard. Standard form is ax plus by equals c. And there's no information that you can pull from a, b, or c. X and y represent a point. All the points that are solutions to this equation. But there are some, and we're going to use it to pull the x and y intercepts. And so when we get it in standard form, we're going to easily find the x and y intercepts. Something to also remember when you're writing an equation in standard form, a, b, and c must be integers, and a must be positive. That doesn't mean that when you get it from an assessment that that's going to be the case, but when it's in standard form, x and y are on the left side, your constant's on the right. So this is in standard form, x and y are on the left side, and then your constant's on the right. And this is technically a standard form that you can submit. A is 1, B is -1, C is -4. So let's now talk about how we sketch this. Well, we want to find the intercepts. So if you were going to look for the x-intercept, we know that y equals 0. Every x-intercept y value is going to be 0. So you take this equation, x minus y equals -4. Make sure that that's the correct equation. We're going to plug in 0 for y. And we get x equals -4. So we plugged in 0 for y. And when y was 0, x was -4. And that is an x-intercept. So we go to -4 on the x-axis, 0 on the y-axis. That is my x-intercept. And then we're going to find the y-intercept, which means whenever you find the y-intercept, x always equals 0. So we again take this equation and we plug 0 in for x. And we have to solve for y. So we still have to multiply by -1 in order to get y to be positive. Y equals +4. So we plugged in 0 for x and got 4 for y. That's the coordinate. And that would be 0x, 4 for y. We're going to connect those 2 dots. We're going to put arrows on them. And then we're going to label our points. That's -4, 0. And this is 0, 4. I got 2 points. I've got 2 coordinates. I have my line with an arrow. That's how we find the 2 points when it's in standard form. That's the easiest way. So here again, we have x-intercept. Y is going to equal 0. So if y equals 0, what's going to happen to that term? 3 times 0 is 0. It's going to go away and leave you with 2x equals -6. So we can cut that piece out. We can go straight to this. And then we're going to divide by 2. Now we solve for x. And we get x equals -3. That is my x-intercept. So on the x-axis, we go to -3, make a dot. To find the y-intercept, as we mentioned, x equals 0. Well, if I put a 0 in for x, what's going to happen to this term? It's going to be equal to 0. Go away, and we'll just be left with 3y equals negative 6. I call this the cover-up method because we cover up the other term. And we'll divide by 3, leaving us with y equals negative 2. And that's my y-intercept on the y-axis. We'll connect the dots, draw some arrows, label the points 0, negative 2, negative 3, 0, and we're done. It's in standard form. X-intercept will cover up the y because y equals 0, and we're left with x equals 0. Cover that up, you're left with x equals 0. To find the y-intercept, we're going to cover up the x, and we get 3y equals 0. Divide by 3, y equals 0. This is a good tricky one. So my x-intercept is 0, and my y-intercept is 0. It's the same point. So I can't draw a graph at the moment. So in this particular problem, I have an additional step. I have an additional, that's not how you spell additional. Additional step. I have to find a second point. I don't have a second point to draw my line. So there's a couple things we can do. We can use an H chart. You want to use an H chart? Use an H chart. We can do this. X, this is the equation. X plus 3y equals 0. And our y, we can plug in an x value. You want to plug in 1? Plug in 1. 1 plus 3y equals 0. Minus 1, minus 1. 3y equals negative 1. Divide by 3. Divide by 3. Y equals negative 1/3. Negative 1/3. So my coordinate, my xy coordinate is going to be 1 comma negative 1/3. That's okay. It's not great. 1 negative 1/3 is right there, so it's kind of close. But it's a point. We know it's a solution, and we can still connect those two dots. We can connect them, and then we label our points. And we know that those are solutions. So we draw that, we label 0, 0, and we label 1 comma negative 1/3. That's fine. The other technique you could have done, you could have taken the equation x plus 3y equals 0, and you could have solved for y. Subtract x, 3y equals negative x, divide by 3, and we get y equals negative 1/3 x. So we know my y-intercept is 0. We already plugged that, but here's my slope. So I could have gone down 1, right 3, which is right here. So we could have found an additional point in that manner. Let's move that 0, 0 down to the other side. And then, so I graphed it a little incorrectly. That's not a good graph. Again, 1/3 is hard to graph, so you're going to get some funkiness in your accuracy because they're so close. But that's better. That would have been a better graph, but it's okay. And then you write your coordinate, which is 1. Ooh, that's negative. That's 3, negative 1. There you go. That's better. That point is 3, negative 1, 3, negative 1. And again, my slope was down 1, right 3. So either way, you can use your H chart or you can solve it and use the slope off of your intercept to find a second point. All right, this is slope-intercept form. So the second linear equation is slope-intercept form. And that form is y equals mx plus b. X and y are still coordinates. They're points on the line. M represents the slope of the line, and B represents the y-intercept. So we see the slope, which is the coefficient of x. It's the number in front of x. It's not the x itself. And then B is the y-intercept. So -5 would be my y-intercept. So I have a slope of 2/3 and a y-intercept of -5. We always plot the y-intercept first. We need a point. Slope is from point to point. So I don't have a point. I can't go up 2, right 3 from anywhere because I haven't placed myself on this coordinate. So I know this point is a point on this line. -5 is the y-intercept. Now I'm going to go up 2, right 3. I'm going to connect the dots, draw my arrows. I'm going to label my point 0, -5, and this point is going to be 3, -3. It's not 2, 3. It's from the origin, so be careful of that. Good. So that is good information there on how to do that. So jumping right to it, my slope is -6/5, which is either -6/5 or 6, -5. Only one negative, one negative, one negative, one negative. Outside, numerator or denominator. My y-intercept is going to be -3. So here's my y-intercept. I'm going to go up 6, 1, 2, 3, 4, 5, 6, and then left 5, 1, 2, 3, 4, 5. So that is up, that is left, that is down, this is right. This is the coordinate -5, 3, and this is the coordinate 0, -3. Look how fast and efficient we are. I like this. Slope is equal to 1, y-intercept is equal to 0. 1/1, that's up 1, right 1, off of the y-intercept, 1, 1. We didn't need that many points, we just needed 2. But I got you some extra just because I was excited to graph. That's going to be 1, 1. This is going to be 2, 2. And we're done. All right, now this is not in an equation. First of all, there's only one variable, so that should be interesting. But I want to get it. I'll solve for x. I'm going to multiply by -1. That'll get my x to be positive. Now, when I have a single variable, I know it's either horizontal or vertical. Since I have the variable x, it's going to go through the x-axis at -3. So the x-axis at -3, and it's a statement. It says, hey, x must always equal -3. So that's going to look like this. Every point on this line, my coordinate, and I'm going to pick another one because I need 2 points. This is going to be -3, 3. This is -3, 0. And notice every point, my x value is -3. This is not in any format. It's not standard, and it's not slope-intercept, and it sure as heck is not point-slope. So I'm going to have to manipulate it. That's my easiest way to do it. And I'm going to solve for y. So I will add 2 to both sides. Gives me -2y minus 3x equals 2. I'm going to add 3x. Gives me -2y equals 3x plus 2. And then I'm going to divide by -2, excuse me. Everything by -2. Y equals -3/2 x minus 1. Now I have my slope, which is -3/2. I have my y-intercept, which is -1. -1, I'm going to go down 3, 1, 2, 3, right 2. I could have gone up and left, but I chose to do this. There is no right way. There's going to be lots of different points. Arrows. This is 0, comma, -1. This is 2, comma, -4. Again, it's not in any format, so it's pretty close to slope-intercept form. So I'm going to isolate y. It's being multiplied, so I need to multiply by the reciprocal. And here's the tricky part of this. I got to multiply everything. I got to multiply the x and the -5/4. That gives me y equals 4/5 x, and that's going to give me -1. So a slope of 4/5, a y-intercept of -1. Lots of -1 intercepts. Slope of 4/5, 1, 2, 3, 4. Right, 1, 2, 3, 4, 5. Connect them. Zero, -1, 5, 3. Write an equation for the line in all three linear forms: point-slope form, slope-intercept form, and standard form. So the one that we didn't talk about was point-slope. Point-slope is y minus y sub 1 equals m times the quantity x minus x sub 1. And so we need the slope and we need a point. Well, the slope, let's pick 2 points. So I got this point here, which is 2, -4. And I got this point right here, which is my y-intercept. That's 0. -1, no kidding. All right, so we're going to fill in for y sub 1 and x sub 1 and my slope. So let's calculate the slope. Slope is up 1, 2, 3, up 3, and then left 2. So that gives me 3 over -2. So that's my slope. So I'm going to pick a point. Let's pick 2, -4. So y minus my y sub 1, that's my y value, -4 equals -3/2 times the quantity x minus my x sub 1 value, which is 2. You got to pick both the x and the y from the same point. So my final answer is going to be y plus 4 equals -3/2 times the quantity x minus 2. That is one of an infinite number of solutions. Whatever point you pick on there is the one you're going to plug in. But that was for A. B, slope-intercept form. So slope-intercept form is y equals mx plus b. And we have the slope already, and we have the y-intercept. So we can just plug that in. That's going to be y equals -3/2. That's my slope. And then my y-intercept is going to be -1. So that is the B. Now, to get standard form, as we already talked about earlier, standard form, we'll do this. We can take either of these. This one's much easier. We'll take the slope-intercept form, and we'll move that x over, because x and y have to be on the same side, and my constant has to be on the right side. So this gives me 3/2 x plus y equals -1. Now, remember my a, b, and c need to be integers. A, b, and c must be integers. That means whole numbers are their opposites. And then the other stipulation is a must be positive. So it is already positive, it's just a fraction. How can I get rid of that 2 in the denominator? By multiplying by 2 in the numerator. And I multiply everything because I got to keep it proportional. So that gives me 3x plus 2y equals -2. 2 times 3/2 x gives me 3x. 2 times y gives me 2y. 2 times -1 gives me -2. And that is going to be the solution in standard form. That's the C part. Same thing here. What? Is that like the same formula? All right, here's a point. That's a good point. And let's pick a point up here. That's a point right there. So that point is -5, 3. This point is 0, -1. Y-intercept of 1, -1 again. So A was point slope. So y minus my y value, 3, equals, well, let's calculate my slope. Sorry. My slope is up 1, 2, 3, 4. Up 4, and then left 1, 2, 3, 4, 5. Which simplifies to 4 over -5. So my slope, 4 over -5, times quantity x minus my x value, which is -5. Let's simplify that, just the double signs. We're not distributing or anything like that. X plus 5. That is in point slope form. Let's do standard form. So that's y equals my slope times x, and then -1 because that's my y-intercept. And now if we're going to do standard form, we're going to take that equation in slope-intercept form, and we're going to move the x over. Move the x over gives us 4/5 x plus y equals -1. We can't have 5 in the denominator, so we'll multiply everything by 5. And my final answer is going to be 4x, because the 5's cancel, leaving you with 4x, 5y equals -5. Those are my 3 formulas. Oh, this is nice. So, point slope. So, if you want to do point slope, you could do y minus. This y-intercept is a coordinate, 0, 1. So you can put -1 equals -3/2 times the quantity x minus 1, because we put, no, x minus 0, sorry. X minus 0. That's one of many points. You could have gone to this step, y equals -3/2 x plus 1. You could have found another point by plugging in an x, doing the H chart, plugging in an x, finding out the y, and then using that as your point. But this is way easier. Don't overcomplicate it. So here we have the equation y equals -3/2 x plus 1. Let's minus the x over, leaving us with -3/2. Oh, adding the x over. Hello. Were you wondering what I was doing? Adding the x over. 3/2 blue plus y equals 1. Let's multiply it by 2. And that gives us 3x plus 2y equals 2. That is standard form. Same thing, we are given the slope and the y-intercept, so A. So my slope, this is the point 0, -2. So we can do that. Oh, my arm hurts. Y minus -2 equals 2. That's my slope. Times the quantity x minus 0. And that gives us y plus 2 equals 2 times the quantity x minus 0. That's standard, or that's point slope form. Slope intercept form is y equals 2x minus 2. And then standard form, y equals 2x minus 2. Let's subtract the 2x over -2x plus y equals -2. can't have a negative, so we multiply by -1. Everything else are integers, so that's okay. So 2x minus y equals 2 is the standard form. All right, it's in standard form, so my C equation is already done. I'm done with that. That's cool. And I'm not going to do, well, I can't do point slope. No, because I can't see the slope and I can't see the point. So I'm going to actually go immediately to this. So we're going to take 3x plus 6y equals -24. And we're going to minus the 3x because we're going to solve for y to get it in slope-intercept form. 6y equals -3x plus 24. We're going to divide by 6, divide by 6, divide by 6. And my equation in slope-intercept form is -1/2 x plus 4. Make sure you simplify that fraction. So now I see the slope and I see a point. Now let's pick a different point. I don't know, let's plug in one. Find a point. So if we wanted to find a point, let's pick an x value. Let's say x equals 1, and we're going to plug it in for x. Let's use 2, sorry. 2 is going to be better because it'll cancel. 2 multiplied by 2 plus 4. I'm just taking this equation, y equals -1/2 times x. I'm picking an x value. So y equals -1 plus 4. Y equals 3. So I have a point 2, 3. So when I do point slope, it's y minus 3 equals -1/2. That's my slope times the quantity x minus 2. Notice the point I plugged in. And then C, it's already in standard form, 3x plus 6y equals -24. I didn't have to do anything. Now I could have used the y-intercept, that's 0, 4, and plugged in 0, 4, but I'm just showing you other ways. This is not standard form. So again, I could plug in and find, but I'm going to make it a little bit easier. I'm going to wait on point slope, and I'm going to do y-intercept or slope-intercept form first. And I'm going to write this with the y first. -6y equals 9x minus 12. I just rewrote it -6x on the left, right? Because that's over on this equal sign by itself, and then I just flip these. And now we're going to divide everything by -6, giving me y equals 3 over -2 plus 2. That's in slope-intercept form. I now have my slope, and I can pick a point. Let's find a point for fun. This time we're going to plug in 2 again. So let's make x equal 2, y equals 3 over -2 times 2 plus 2. Y equals, these cancel, that makes -3 plus 2. So y equals -1. That coordinate is 2, -1. We'll use it in our point slope formula. Y minus -1 equals -3/2 times the quantity x minus 2. Let's get rid of those double signs. And that's point slope form. And then standard, it's kind of close to standard. Let's move that 9x over. So you have -6y equals 9x minus 12. Let's move the 9x over to get x and y on the same side. -9x minus 6y equals -12. And we can just multiply it by a -1. If we multiply it by -1, you get 9x plus 6y equals +12. That is one of an infinite number of standard forms also. You could have gotten 3x. 3x plus 2y equals 6. That's one of them. That's a multiple of that. There's lots of them. There's an infinite. I like this. This is good. So let's find the slope. Remember, slope, you use y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This is my point 1. This is point 2. So this is x sub 1, y sub 1. That's my x value in my first point, my x value in my second point, y value in the second point. So if we substitute y sub 2, that's 3 minus 0 over negative 5 minus 2, which leaves us with 3 over negative 7. That's good, right? That looks correct. And now point slope. So we'll pick one of the points. I'm going to pick point 2. So y minus 3 equals negative 3/7 times the quantity x minus negative 5, leaving me with y minus 3 equals negative 3/7 times the quantity x plus 5. Slope intercept. This is not the y-intercept. This is the x-intercept. Don't know if you knew that. And so if you want to find the x-intercept or the y-intercept because it's in slope-intercept form, well, we know if we want to find the y-intercept, you plug in 0 for x. So, oh, no, let's not do that. Hello. That's time-consuming, too time-consuming. Well, let's take this equation, y minus 3 equals negative 3/7 x plus 5, and let's distribute. Remember, if we want to convert from point slope to slope intercept, we distribute, giving us y minus 3 equals negative 3/7 x, and that's going to be minus 15/7. And now we move this over. So distribute and then move the constant. So we'll add 3 to both sides. 3 and 7th is 21/7. I notice I have to get the 7th, so instead of writing plus 3, and then I'm smart enough to know, so this is y equals negative 3/7 x, and that's going to give me plus 6/7. That's in slope-intercept form. Okay, yeah, now standard, we're going to have to do a little bit more work too. Y equals negative 3/7 x plus 6/7. That's a good one. There's a lot of work. We're going to add 3/7 x to get my variable over, giving me 3/7 x plus y equals 6/7. I can't have a fraction. I need integers, so I'll multiply everything by 7. Multiplying everything by 7 gives you 3x plus 7y equals 6. And that's the equation in standard form. 2 points again. So let's find the slope. Slope is going to be 4 minus 0 over 1 minus 5, which is 4 over negative 4 or negative 1. That doesn't look like a negative 1, which is negative 1. Okay, so point slope, pick a point. We'll pick this point. Y minus 4 equals negative 1 times the quantity x minus 1. That's good. Slope-intercept form. We'll take the point slope form. We will distribute. And then we'll move this constant over every single time. 2 steps to get from point slope to slope intercept. Y equals negative x plus 5. And then we'll take this slope intercept form and we will move the x back over. X plus y equals 5. A, B, and C are integers. A is positive, so we are good. All right, these next 4 problems, last 4, deals with lines that are parallel. So we got to write it in point slope form that is parallel to this. Okay, well, if it's parallel to it, then I know that lines that are parallel have the same slope. So if I'm going to put it in point slope form, that's nice and easy. Y minus my y value equals, here's my slope, because parallel lines have the same slope, x minus my x value. We're going to get rid of those double signs. And we're going to write, and there it is. That took real quick. Same thing. If they're parallel, then I know that my point or my slopes are going to be the same. I have a point, y minus -2 equals -3 halves times the quantity x minus -2. Let's get rid of those double signs. And we're good. Now write it a linear and slope intercept form, and it's perpendicular to it. Okay, this is a little tricky. So this one I'm going to just visualize. Okay, so x equals 0. So x equals 1, x equals -1, -2. X equals 0 looks like this line. Okay, and if it's perpendicular and goes to the point -3, -1, -3, 1, 2, 3, -1, it goes through this point and it's perpendicular, well, that line must be horizontal. And this point is -3, -1. I know the equation of this line is going to be y equals -1. That is that equation because it's horizontal with a slope of 0 and a y-intercept of -1. That's a good tricky one. All right, perpendicular. So what do we know about perpendicular lines and their slopes? It is the opposite reciprocal. Opposite reciprocal. So if it's 5/4, then I take the opposite and flip it. So that's my new slope. That's my slope of the line perpendicular to it. And we got to do it in, what did they say? Slope intercept? Slope intercept form. So y equals, here's my slope, -4/5 x. And this is not an intercept, so I don't know what my intercept is. I do know what my x and y is, so I can plug that in temporarily. I'm going to put 2 in for y. -4/5. I'm going to put -3 in for x, and I'm going to solve for b. So that gives me 2 equals 12/5 plus b. Let's subtract 12/5. Let's subtract 12/5. This is equal to 10/5. So that gives me -2/5 equals my y-intercept. So I can take that information and I can write my correct slope-intercept form. -4/5 x minus 2/5. That is the equation in slope-intercept form. There you go. All right, that was pretty long, but good. You should know how to do all of those things for the assessment coming on Tuesday or Wednesday. Good luck. Come and see me if you have questions. Use Skills Trainer. Use the extra practice. Use the reteaching. Good luck.